Storage Spaces is a new technology in Windows 8 and Windows Server 2012 that has benefits from individual consumers to the largest enterprise customer. Many customers have tried the gamut of storage solutions from JBOD arrays to RAID boxes or NAS boxes. Many of them have been hoping for an approach architecturally that's a little more closer to NTFS and integrated with Windows more directly. Windows 8 and Windows Server 2012 storage improvements are designed to do just that with storage spaces. The existing solutions customers already use will continue to work fine in Windows 8 and Windows Server 2012, but many will appreciate this new feature and the flexible architecture of storage spaces. Storage Spaces is a new technology in Windows that allows you to virtualize storage to achieve scale, resiliency, and improve efficiency. Storage spaces are going to dramatically improve how you manage large volumes of storage at work and at home. Now, while the existing storage solutions you have in place today will continue to work fine with Windows, we think you'll appreciate this new feature and the flexible architecture it provides. Storage Spaces is a technology available in both Windows 8 and Windows Server 2012 and can scale from home use scenarios like large digital libraries of video and photos with Windows 8 to helping with storage challenges with the enterprise with Windows Server 2012. With storage spaces, I can organize my physical disk into storage pools, which I can easily expand by simply adding disks. The disk can then be connected either through USB, SATA, or SAS. This means storage pools can be composed of different size disks available through different storage interconnects. With storage spaces, I can create virtual disks called spaces. These behave just like physical disks for all purposes. Spaces, however, have powerful new capabilities associated with them, such as thin provisioning, as well as resiliency to failure of the physical disks. For this demo, I've created a simple pool with these 5 USB drives that you see here. If we look in the storage space management console, you can see I have 1.45 terabytes of capacity. Now, with that pool, I've created 3 spaces for teams in my organization. I have 2 5 terabyte spaces for each research and finance, and a 10 terabyte space for marketing, since marketing always seems to use up more drive space. Now, these 3 spaces use the same storage pool, so I can efficiently use the physical drive space to support the different needs of my customers. You might be wondering, how can I create 20 terabytes of space on 1.45 terabytes of physical drive space? Well, this is called thin provisioning. With thin provisioning, the actual capacity is reserved for the space only when you decide to use it. For example, when you copy some files to a volume on this space, previously allocated physical capacity can be reclaimed safely when the files are deleted. This reclaimed capacity is available for usage by other spaces on the pool. Now, you might wonder what happens when I approach the limits of the available physical capacity written within the pool. Well, when that happens, storage spaces will notify you, and you can simply do this by adding some additional drives to the pool. With prices generally falling over time for storage and capacity increasing with this thin provisioning, you can provide users with the space they request while stretching your hardware budgets by purchasing space only when you need it. We've seen how with thin provisioning, I can efficiently meet my storage needs, but what about resiliency? How do you ensure consistent access to critical business data? Another core capacity associated with storage spaces is resiliency to failure of the physical disks in the storage pool. Every space can have one of 4 settings for resiliency. At its lowest level, they can have no resiliency. This will give you the maximum space usage on the physical drives, but will give you no protection in the event of a drive failure. A space can be mirrored. In mirroring, the data is completely copied on 2 different drives. You can also select to have a 3-way mirror as well. The last resiliency setting is parity. Parity stores some redundancy information within each space to enable the ability to automatically reconstruct the data in event of a drive failure. To demonstrate the resiliency of storage spaces, I'm going to start a video here that I have stored on the marketing space. I'm going to play this video snapped to the side of the screen so you can see both the video and Stored Spaces Management screen. Now, you can see the video plays with no problem. Now, I'll reach down and disconnect one of these drives in my pool. Let's see what happens when I unplug a second drive. You see, with two drives removed, the video keeps playing with no issue. You can see in Stored Spaces screen that it realizes that two of my drives have been removed. Let's plug one of the drives back in and remove another drive just to see what happens. You see the video just keeps playing with no issues. Even when I remove two of the physical drives, the space is available and my users have constant access to their data. As you've seen, Stored Spaces is a new technology in Windows that allows you to virtualize storage to achieve scale, resiliency, and improve efficiency. With Stored Spaces, you can dramatically improve how you manage large volumes of storage at work and at home. And while the existing storage solutions you have in place today will continue to work fine in Windows, we think you'll appreciate this new feature and its flexible architecture.